Welcome to homework.
In the first part of this problem, we are going to calculate the angular velocity of the rod BC, that is omega BC. In order to calculate this angular velocity, we need to find different displacements and then the speeds of different components of the system. So let's start by writing RC as RC is equals to XCI plus into 640 millimeter J. We can also write RB as RB is equals to 24 inch of J plus 10 inch K. We can write the length of the rod AB as LAB is equals to square root of 24 whole square plus 10 square. So from here we can write the value for this LAB as LAB is equals to 26 inch. We can write the equation for this vector R C slash B as R C or B is equals to XCI plus 8 inch J minus 10 inch K. The length of the rod BC is given by the equation LBC whole square is equals to 42 whole square. So this can be written as this is equals to XC square plus 8 square plus 10 square. So from here we can write the value for this XC as XC is equals to 40 inch. Now the vector RCRB is written as RCRB is equals to 40 inch J plus 8 inch 40 inch I plus 8 inch J minus 10 inch K. Now we can write the velocity of B as VB is equals to 19.5 divided by 26 into minus 24J minus 10K. So from here this can be simplified as minus 18 inch per second J minus 7.5 inch per second K. We can write the velocity of C as Vc is equals to Vci, where this Vc is the magnitude of this vector. We can write the angular velocity of color C as omega C is equals to omega Ci. Since the axle is perpendicular to the x-axis and the rod BC, so a vector along this axle is written as P. So this is equals to I cross RCB. So this P is a vector which is parallel to the axle. Now this can be written as P is equals to I cross into by inserting the value of this RC into this equation, we can write this one as 40 I plus 8J minus 10K. So this is equals to 10 each of J plus 8 each K. the magnitude of this vector will be p is equals to square root of this 10 square plus 8 whole square. So this is equals to 12.81 inch. The unit vector of this vector p is written as lambda. So this is equals to p vector divided by the magnitude of p. So this can be written as 0.781 j plus 0.625 k. The angular velocity of the rod BC relative to the color C is written as omega C, omega S. So this is equals to omega S lambda. By inserting the value of this unit vector omega lambda into this equation, we can write omega S is equals to 0.781 omega S j plus 0.625 omega S k. Now we are going to write the angular velocity of the rod BC. So it will be omega BC. This is equals to omega C plus omega S. We use the vector addition rule in this case. So this is omega S. Now we can write the velocity at C as Vc. So this is equals to Vc I, and this is equals to minus 18j minus 7.5 k plus ijk, determinant ijk, and here we have omega C 0.781 omega S and then 0.625 omega S. Here we have to write 48 minus 10. Simplifying this equation and then comparing the components of the vectors on both sides, we can write Vc is equals to minus 12.81 omega S. So this will be our equation number 1. 0 is equals to minus 18 plus 10 omega C plus 24.9 988 omega S. So this will be our equation number 2, and the third equation will be 0 is equals to minus 7.5 plus 8 omega C minus 31.24 omega S. So this will be our equation number 3. Now using these three equations, equation number 1, 2 and this 3, we can write different values for the angular velocities. Omega C is equals to values for different angular velocities as omega C is equals to 1.46 radian per second, omega S is equals to 135 radian per second, and then Vc is equals to minus 1.73 inch per second. The vector of this velocity will be Vc, and this is equals to minus 1.73 inch per second in the direction of phi, and this is the answer to the part B of this problem. Now we can write the angular velocity of the rod BC as omega BC is equals to 1.46 I plus 0.11 J plus 0.84 K radian per second. So this is the required answer of the part A of this problem. End of the question. Thank you.